Hi guys, so we're gonna go ahead wrap up our unit on quadratic equations by looking at this application problem. So it says application of a quadratic function, and it says border or walkway around the planting area. So I guess we're gonna look at a planting area and then put a border or walkway around it. Cool. So I'm going to make this problem a little bit spicier. So I'm going to change the plans. So I'm going to change the number 500 to 450, which right now it's like no big deal. Why should we do it? It's actually because I want the numbers to be a little bit more exciting. So with that being said, let's go ahead and read it from the top. So it says a gardener has a 30-foot by 25-foot rectangular plot of ground. She wants to build a brick walkway of uniform width on the border of the plot. If the gardener wants to have now 450 square feet of ground left for planting, how wide to 2 decimal places should she build a walkway? Now, I understand that we have access to a graphing calculator, so for that reason, I try to be very clear on when you can answer graphically or when you have to answer algebraically, and this is one of those cases. So yeah, you can use your calculator for computations, but you need an answer. Your answer needs to be supported by your work. Okay, so let's do this. So from the top, a gardener has a 30-foot by 25-foot rectangular plot of ground. So we have some land in the form of a rectangle. Okay, so I'm a very visual person, so I'm gonna do a picture. Whenever I do a picture, I do it to the far right, so that way I have space to show my work on the left. So I'm gonna do a rectangle to the best of my ability. Cool. Okay, so that's the piece of land that we have in the form of a rectangle, and the dimensions is a 30 feet by 25 feet. So the longer side should be 30 and the shorter side should be 25 feet. Okay, so far so good. Okay, she wants to build a brickway of uniform width on the border of the plot. Okay, so we want to a brick walkway. So we want to make a walkway of uniform width. Uniform meaning being the same. So it's not like it's gonna be the same all around. It's not like this part is like this and then this one is wider. No, same. Okay, same width. She wants to build a brick walkway of uniform width on the border of the plot. So the question is, where should the border go? So I'm like, should we put it at the edges or should we put it inside? Well, the walkway needs to be on the border of the plot. We can't put it on the outside because that's outside our land. So we need to put it on the inside. So let me go ahead, take like a highlighter or something. Hold on. So something like this. Same width. I tried. It looks a little bit wider on some sides. Yeah, I was trying to redeem myself. That didn't happen. Okay, so I'm not too sure how well the highlighter translates on the screen. So let me just go ahead do it with my pen. Okay. Okay, so we want to make a border of uniform width or same width all the way around. Cool. On the border of our plot. Okay, cool. If the gardener wants to have 450 square feet of ground left for planting. Okay, so we make our walkway on the border of the plot, and the leftover space should be 450. So let me just go ahead and put 450 square feet, and that's gonna be the measure of the inside or area. Okay, the question says how wide to 2 decimal places should she build a walkway? So what is the width? No idea. Okay, but we're just gonna call it, it's gonna be X feet wide. Okay, you don't really have to do what I'm doing right now, but it helps me just to emphasize that this distance is X feet. Okay, so this is like in my way, so I'm gonna go ahead transpose the planting area only. Okay, so I'm gonna put planting area. I know that the planting area should be 450 square feet. Cool, fantastic. And it would be nice if we wrote down the dimensions, the width and then the length. Cool. All right. So now I want to know what is the length and width of the planting area. So we know that the land the whole way across is 30 feet. Okay, but the planting area is not gonna be 30 feet wide because we removed some of it for the walkway. So from here to here the distance is x feet. From here to here the distance is also x feet. But the question is, what is the length of the walkway? The whole way across is gonna be 30 feet. We gotta subtract this piece right here from the walkway, so we're gonna subtract x feet. Then we gotta subtract this piece right here, you know, for the width of the walkway. So if the whole way across is 30 feet, then the planting area is gonna be 30 minus 2x feet. Okay, let's bring that to our problem. So what is the length of the planting area? That. 30 minus 2x feet. Now it will be nice if we had an expression for the width of the planting area. The whole way across is 25 feet, but we don't have 25 feet for the planting area because we gotta remove some space for the walkway. So from here to here we have x feet. For the bottom part we also have x feet. The whole way across is 25. The leftover will be the planting area. So we have 25 minus x minus x. So minus x, the width of the top part, minus x, the width of the bottom part. All together, it looks like the planting area is 25 minus 2x feet wide. Fantastic. So now, because they gave us some area, then I guess we're going to use the area formula. So we have A equals length times width. Sorry, I'm a little nervous. We have that the area equals length times width. We know what the area should be, or what we want it to be. We want it to be 450 square feet. We are going to multiply that by the length, which is 30 minus 2x. And we're going to multiply it by the width. Now, I'm always very careful with the domain. Although we don't have to write the domain of this equation, it's in your best interest if you do. We know that length or measurement is not negative, so like the width can't be like -2 feet, okay? So what would the domain have to look like? So length or measurement is non-negative. The only way we're going to tell the reader that our length or measurement is not negative is if we specifically say, hey, you have to be bigger than 0. Okay, so let's take our expression for the width and tell the reader that it can't be negative, or let's make it greater than 0. Let's go ahead and solve this and see what we get. So to isolate the variable term, we will subtract 25 from both sides. When we do, that will give us -2x is greater than -25. It's just in my way. Okay, to get rid of the times -2, let's go ahead, divide both sides by -2, and that will give us, don't forget to reverse the direction of the inequality symbol when you multiply or divide by a negative. So that will give you x is less than 25 halves, or which is 12.5 or 12.5. I'm going to give the people what they want. So what do we know about our x value? The domain is that x has to be less than 12.5, but I'm going to see if I can restrict the domain more. Okay, so let's go ahead, look at the length. The length or measurement also can't be negative. So the only way we're going to tell the reader that our length is not negative is if we say it has to be bigger than 0. Expression for the length is given by 30 minus 2x. So let's go ahead, work our magic, and see what the domain is. Okay, isolate the variable term. We'll subtract 30 from both sides, and that will give us -2x is greater than -30. I'm out of space. After we divide both sides by -2, that should give us x compared to 15. Don't forget, whenever you multiply or divide by a negative, you gotta reverse the direction of the inequality symbol. So we have x is less than 15. So what do we know for the domain? We have that the domain has to be x has to be less than 15, and at the same time it has to be less than 12.5. We're gonna look at the one that's a little bit more restricted. So we want to tell the world, I'll just put where x is less than 12.5. okay, but it also can't be negative, so we're gonna say and it's also greater than 0. So if you don't put this, it's no big deal, but this will help us, this will put us on check. Okay, so let's go ahead, work our magic, and then solve the equation on the left, taking into consideration the domain. Okay, so on the right side, let's go ahead, FOIL it out, or do what you gotta do. Product of the first terms will give us 750. Product of the outer terms will give us negative 60x. Product of the inner terms will give us negative 50x. And product of the last terms will give us 4x squared. Fantastic. Let's go ahead, clean up the right side. Continue to clean up the right side. We have one squared term, so we have 4x squared. The sum of the middle terms will give us negative 110x. The constant term is just 750. Fantastic. We got this. So we have a degree 2 equation or quadratic equation. We can try to solve by factoring, quadratic formula. I myself am a big fan of factoring, but these numbers are out of my zone, so we're just going to go straight to quadratic formula and then use our calculator. So let's go ahead solve it by using quadratic formula. First things first, let's go ahead, set this equal to 0. So we will subtract 450 from both sides. And that will give us 0 is equal to 4x squared minus 110x plus 300. Okay, I think. Fantastic. So let's go ahead, take our time, and then write down the quadratic formula. Give me a second. Alright, I found it. Okay, cool. So where was I? So we're going to go ahead, solve this equation by using the quadratic formula. In order for us to use the quadratic formula, we have to set the equation equal to 0. Done. So let's go ahead, bust out the quadratic formula. So if this is our question, what would the answer look like? So we have x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. I know you missed my singing, but I wanted to save you. Okay, so let's go ahead. We nailed the formula. Let's identify a, b, and c for our peace of mind. Leading coefficient is 4. That's our a. Coefficient of the middle term is negative 110. That's our b. Constant term is 300. That's our c. So let's go ahead, plug and chug. So we have x equals opposite b. Value of b is negative 110. And you know that I like to use both hands. Plus or minus the square root of b squared. Value of b is negative 110. B is what squared? Minus 4 times a. Value of a is 4. And value of c is 300. Bear in mind that we are not an arithmetic course, so we are in this course because we at some point we can like add, subtract, multiply, divide pretty good without the use of our calculator. But this is not an arithmetic course, it's an algebra based course, so we're gonna use our calculator a lot at this point. Okay, to continue the formula, that's gonna be all over 2a or 2 times 4. So we have x equals opposite of negative 110 is positive 110, or in English, negative times a negative is a positive. I'm not gonna try to impress you with my amazing math skills. I already told you me and arithmetic don't get along, so I'm not really gonna try to do that in my head. I'm just gonna go straight to the punchline. Okay, so if we're gonna use a calculator, there's really no need to show what the square of negative 110 is. There's really no need to show what this product is. Let's just go ahead, punch in our calculator to see what that radicand gives us. So we have square of negative 110. And again, pause and rewind as many times as you like. Minus 4 times 300. And that gives us 7,300. And that's going to be all over 8. Okay, so again, this is just strictly arithmetic. There's really no need to simplify the radical. If you want to, go ahead, but it's not necessary. Let me just write it without the plus or minus. So we have that one solution is given by 110 plus the square root of 7,300. And that's all over 8. And another solution is given by 110 minus the square root of 7,300. And that's all over 8. Fantastic. So let's go ahead, punch it in. The directions say that we need to round to 2 decimal places. The popular mistake is that students will evaluate the square root of 7300, round that, and then round at the end. But that's not how rounding works. When we round, we want the entire solution to be exact. Then in the final statement, we go ahead and then round it at the very end. Alright, so let's do this. So we're just gonna punch it in. So we have 110 plus the square root of 7300, and then we'll hit enter, and then we'll divide it. Notice how I'm not gonna round. We're not gonna clear it either at this point. At this point, we'll finish it off divided by 8. Okay, so now we can safely round to 2 decimal places. So we have that x is about 24.43. And then the other solution, we have whatever this is, 110 minus the square root of 7300. Let's go ahead, hit enter, and not erase it. Okay, so that is the difference, and then we're gonna put divided by 8 to 2 decimal places. That's about 3.07. So the question is, what is the answer? The question reads, how wide to 2 decimal places should she build a walkway? According to our illustration, the walkway should be x feet wide. So I'm at a crossroads. Should it be 24.43 feet, or should it be I can't even read my own writing. Or should it be 3.07 feet wide? Well, you could just guess, but no, guessing will get you wrong answers. We had written an expression for the area, but now we have to take into consideration the domain. Good thing we talked about domain. So we had said that x has to be between 0 and 12.5. Last time I checked, 24.43, it's outside the zone. Okay, so it's outside of the domain. So in this case, we're just going to go by 3.07 feet. Do me a favor, write this in a new line. Don't be sloppy, and then just box it right there. Okay. So the moral of this story is that the walkway needs to be 3.07 feet wide about. Fantastic. That's my time. Until next one.